Hi everyone, welcome to today's talk on image and video classification with Keras and TensorFlow. So let's have a quick look at our agenda for today. First, we shall take a look at image processing and different techniques for it. Next, we will talk a bit about video processing. We move on to a brief introduction to TensorFlow and Keras. We will discuss on-device ML with TensorFlow Lite. Finally, for the beginners, we will look at a demo to create our own image classification model without writing a single line of code. So let's get started. An image classifier classifies images into different categories. If you had two pictures of a cat and a dog, or had a list of different digits and you wanted the computer to recognize them, you would use an image classifier. For this, images are represented as NumPy arrays of individual pixels. Color of each pixel can be represented as an RGB triplet. So here we are looking at a CNN. The first part, which consists of the convolutional layers and pooling layers, is the feature extractor, and the final fully connected and output layers are the classifiers. So a neural network has a first input layer, some hidden layers, and an output layer, which predicts the percentages as probabilities of the image belonging to a certain class or not. This depends, the classes that are predicted depends on the kind of data you are training the classifier on. So if you train a classifier with images of cats and dogs, and if you give it an image of a bottle, it won't be able to recognize that, right? So keep that in mind. So let's have a little look at what TensorFlow and Keras is. TensorFlow is an open source library for machine learning and deep learning. Keras is a high-level wrapper on TensorFlow, which makes it easier for us to create, train, and save models. It's a very good choice for beginners. So now let us look at some image classification techniques. So you want the computer to differentiate between images of your pen and your bottle. To classify images into categories, we can have two approaches. First, we can build a CNN from scratch with Keras. But in real life scenarios, we don't really have proper image data sets for everything. So the only option is to build a data set from collecting images from different sources. So if images for each category in our collected data set are limited, say 30 images or 80 images per category, that is too less for a neural network to learn with high accuracy. In such cases, we can take a model trained on a large data set and transfer its learning to our smaller data set. For image classification with the CNN, we freeze the early convolutional layers of the network. So, as we see here, we freeze the early convolutional layers of the network. We only train the last few layers to make a prediction. The convolutional layers extract general low-level features that are applicable across all images, such as patterns and edges, and the final layers identify more specific features within an image, like hair, eyes, a bottle cap, for example. There are several models like VGG16, ResNet, Inception, MobileNet, DenseNet, etc., with pre-trained weights on a massive image dataset like ImageNet. We use them for transfer learning by using these pre-trained weights. We can add custom layers to the model. We can also fine-tune the hyperparameters and unfreeze more layers as required by us. So now let's look at a demo for transfer learning. So let's get started. We import the necessary libraries like NumPy, Pandas, Matplotlib. NumPy is for handling arrays. Pandas is for handling data frames. Matplotlib is for plotting nice looking graphs. CV2 is OpenCV for extracting frames and handling images. Seaborn is again a plotting library, and OS is for mentioning and helping out with some paths and joining paths, etc. So a very important thing is to know which version of TensorFlow we are working on. So for that, we import TensorFlow and print the latest version. So the version we are currently working on is 2.2.0 RC3. In the beginning, we specify some constants like number of classes. We have taken in our data set, we have taken 5 classes of images. So let me give you a look at our data set. So our training data set consists of 5 poses. So this is like the first one is a bridge pose. These are all yoga poses. So the bridge pose, like if someone knows yoga, they'll know. So a bridge pose is a certain kind of a pose. Child's pose is again another pose. Tri-step 1 is the first step of Trikonasana. Stride step 2 is the second step of Trikonasana, and stride step 3 is the third step of Trikonasana. So we will train our data set to recognize these poses. So the number of channels will be 3, as it is fixed for color images in the RGB format. Image resize we take is 2 to 4. And there is the pooling average. The dense layer activation is softmax. We take the metrics as accuracy, although we can have different metrics as well. Here, an important thing to note is early stop patience should be less than number of epochs. Also, the step values here should be a proper factor of the number of images in training and validation folders respectively. Training images processed in each step would be number of trained images by steps per epoch training. These batch sizes are for image data generator of Keras, batching to fill epoch step input. So in this, let's just run these shells, but then, okay, yeah, these are already run. Yeah. So when you click on this shell, this imports drive, and then you can connect your drive to it. So you can keep your data set, you can upload your data set in drive, and then you can directly import it to Colab and use it to train models. Usually we use Colab because we don't have such, like, we can use GPUs on Colab as well, and Colab is faster. So that's why sometimes we choose to use Colab. Also, we can't sometimes store such a large amount of data. If you have a large amount of data, it's difficult to store it on our system. So online storage is better. So here we will mention the training data set. So in my drive, I have stored the training, validation, and the test data sets in a folder called data. So here the train data directory I've mentioned is inside drive / my drive / data / training set. And similarly, I have mentioned the validation data sets as well, and also the test data directories. Next, we mentioned the category names as well and the images per category. So now we shall count, and we'll generate a small graph to look at how many images we have per training class. So for bridge and for all these categories, I collected 80 images for the training set only. So that is what you can see from this graph. This shell, when you run, imports ResNet50, which is your pre-trained model, right? These are the pre-trained weights, and you can import the sequential model and you import the dense layer. So here you define your sequential model, you add all the layers which are in ResNet50, just you remove the top layer, and then you add a pooling. And you also include the weights. Next, you add a dense layer which has the number of classes and an activation function, which is the dense layer activation. This is the model summary. So from ResNet50, it had these number of parameters, and from dense layer, these number of parameters. So the total number of parameters are displayed here. From TensorFlow.Keras import optimizers. Here we import an optimizer and we customize, we provide its learning rate, momentum, decay, etc. Then we compile the model with the optimizer, a loss function, which we took previously as categorical cross entropy, and the metrics, loss metrics, as we took in the beginning. And then we pre-process the input. We put the image size as we defined previously in the beginning, 2 to 4 imagery size, and then we use the data generator to define our train and validation data generators. Here we take a printout of the batch size of training, length of training generator, batch size of validation, just to check that it's all proper factors and everything. Also from keras.callbacks, we import model checkpoint, as we don't want the epochs to keep on going if the loss function is not decreasing anymore. So we want it to stop early and not run for no reason. So that's why we import these. And we save, like for our, we save it in our drive. In the name of the file is best1.h5. So this is the name of the saved model, right? Best1.h5. So here we fit, and then when we run it, here the validation loss is the least. So this is the model that will be saved with validation accuracy 69% approx. So we also get a look at the keys that we have: loss, accuracy, validation loss, and these are the keys that we can use. And here we look at a small graph for the model accuracy and the model loss. So the model accuracy, the validation accuracy seems to be increasing with time as the training accuracy, which is fine. But the model loss, in the model loss part, the validation loss should again be decreasing. And it looks like it has increased, but we know that we have defined a model checkpoint to stop it at this point. So that's that. And then the test, we create a test generator to test and create like a display of images that we have. So as you can see, this is the bridge pose. This is the bridge pose, which I was talking about. And this is the child pose. These are all the child poses that have been classified properly. And this is the first step in Trikonasana. As you can see, tri-step 1 has been predicted. All these, which is again a good prediction. And that's that. So we come to the end for our demo for transfer learning. So let's move on. So let's look at video classification techniques. Coming to video classification, what is the first approach that comes to your mind when you think of video classification? When I think of videos, I think of them as a collection of individual frames. We can make predictions on single images. So we just have to convert our video into a series of frames and get individual predictions on each frame. The class that occurs the maximum number of times is the predicted final class. This is the CNN approach. However, this is not a good approach, as here we are taking only the spatial features into consideration and completely ignoring the temporal features. So, this model will not be able to classify between the actions of opening and closing a door, as these involve time-dependent features. It will just recognize the spatial features of the door. Hence, it will not be able to differentiate. The next approach we can look at is a transfer learning plus LSTM approach. We extract features from the individual video frames and pass these sequences into an LSTM model. An LSTM layer consists of recurrently connected blocks known as memory blocks, as you can see. When you read an essay, you understand each word based on the understanding of previous words, right? LSTMs can remember information for long periods of time. In this approach, we will be using both spatial and temporal features. Hence, the accuracy will definitely improve. I trained and tested my video classifiers on 30 classes from UCF 101 dataset. So UCF 101 dataset is a quite famous video classification dataset with 101 action categories. For each category, there are 25 groups, and each group consists of videos of a certain person performing some kind of an action. Finally, we come to C3D architecture, where we can extract spatial and temporal features directly using 3D convolutional neural networks. Next, there is something I would like to speak about is hosting an ML model on web. So let's move on. Recently, we worked on a Flutter app related to healthcare, which required image classification in real time. We initially went for a CNN model and trained our dataset of images on it. Next, we decided to explore transfer learning on VGG16 with ImageNet weights, which gave good accuracy. So I saved the model and wrote an inference file in Flask to define API endpoints to access the model. Next, I had to Dockerize the application and mention the requirements.txt file as well. The final step was creating an EC2 instance and setting up the Docker container on it, getting the Python app running on it. Well, hosting the model online has a lot of steps. Also, there comes an issue with the latency and also the number of requests that the server can process simultaneously. All this made us try to look at a different approach, which was on-device ML using TensorFlow Lite. With just 2 lines of code, you can convert your existing Keras model into its TF Lite version, and it's ready to be loaded and inferenced on mobile devices. Let me give you a look at the hosted model. So, this is the repo that I used. So, there are 4 things in this repo that are important. This is the H5, the Keras model. This is the requirements file. Let me give you a look. So these are the dependencies that have to be installed on the virtual machine when you are running it. When you create an EC2 instance, you need to install these dependencies in the Docker container. This is the Docker file. Do remember that when you put this line run pip3 install requirements.txt, it is very important to add this line called no cache dir. Otherwise, the space will run out for the Docker container. So here we have mentioned our best1.h5 model as well, and app5.py is our app file. So let's give a look at it. So this is the Python app written in Flask. So let's look at, yeah. So this is the classifier. So here you have a function called load image, where it converts the image to array and then returns it. This image is passed into the model, and then the predicted class is the result, which is returned as the predicted class. So this is hosted at port 80 on AWS. So let's get back. Yeah, so a lot of TF Lite models are readily available to use. So as hosting a model has a very big process, and also there are some issues of the number of requests that the server can process simultaneously, we decided to try out the TensorFlow Lite approach and found it really good. A lot of TF Lite models are very easy to use, and they can recognize join points in like there's a model called PoseNet, which I have used recently. You can pass an image to it and it returns an array of 17 key points, like X and Y coordinates of your join points, like right shoulder, right ear, left ear, eyes, nose, and stuff like that. And that also on your machine. Like, you don't need to host a model for it. You can use it from a mobile app. So Teachable machine is a fast way to create and save machine learning models to use in a web or mobile applications without writing a single line of code. You can train three different types of models on your data: image, audio, and pose. So let's just have a look at it. Yeah. So let's get started. There is the image project, there's the audio project, and then there's the pose project. So image project lets you create and save your models online or download them. There are three options: TensorFlow.js, TensorFlow, and TF Lite. Here you have only the option of TensorFlow.js, and same here, only TensorFlow.js. So let's try out the image project for now. So let's just try it out. The first class can be, let's say, bottle, something that I have at hand right now. So that's that. And the second class, we can have cell phone. Yeah. So that's something that I have right now too. So let's try it out. So let's switch on the webcam and take pictures in different angles of the bottle, away from you, close, and all these. So we have 125 image samples. Let's take some more. Yeah, 225 image samples. That's about good. And for the cell phone, again, different angles, get away from it. We'll stop at 225, so be careful. Yeah, 2 to 6. Fine. So let's start training the model. And here in the advanced tab, we have some different parameters that we can add. Is the number of epochs, also the batch size, the learning rate. We can change all these parameters to get better accuracy models as well. So it's training for now. The training process is quite fast as we just have two classes. So let's wait for it to get completed. Also, you need to keep this tab open as well. It's written. Yeah. So now, look, now we can have live inference for a model. So this is what is happening. You give the bottle, it detects the bottle even if it's away from you, even if it's up there. And even like these, we didn't train it on pictures like this, right? But here is the phone, and again, it detects it as well. Yeah. It's detecting it quite well. So let's switch off the input. Now, after you're happy with the inference of the model, you click on export model. So here again, you have three options: TensorFlow.js, which provides you with a JavaScript inference file, which you can just copy and paste in an HTML page to just get the inference. But one thing, because we did try out this approach, you have to write a proxy server in Node.js or Angular separately to actually connect the outputs of the teachable machine model and the actual outputs. So you have to have another server which will take your image data and it will pass it on to the teachable machine model, and then the prediction will get returned to the proxy server, it will return to you. So that takes quite some time and it was having a lot of latency. Hence TensorFlow, this thing we can, like, this is the inference file. If you download this file called keras model.h5, if you download it, here is the option, download my model. So if you download this model and run this file and pass an image like testphoto.jpg, you can choose any image to try it out. It will show you the prediction. It loads the model. and predicts the image. Finally, we have the TensorFlow Lite. So there are different model conversion types, floating point, quantized. This makes the size quite less. I have tried that out as well. So for now, we'll use the floating point one and we can download the model and we are ready to go. Like, it's very easy to, in any Flutter or Android Studio, we can write code to inference this TF Lite model in our app. So just download the TF Lite model, download your model. It will take some time to get converted and then you can download and then you can use it on your apps. So this was all about TF Lite and Teachable Machine. And thank you everyone for being with me and happy learning, guys. Thank you. And that. So that's about it. Yeah. So that is all about my session on image classification and video classification with Keras and TensorFlow. Thank you all for joining me today. And it was really nice seeing you all guys here. You can leave me questions in the chat if you want, okay? Let me see the chat if there are any questions. Hello, we will have, okay. I can provide the notebook link after the session in the, I will provide the notebook link for you guys. Any reason for using Flask? Yes. Flask, it's really easy to create a REST API, although we can use Django REST API as well, but Flask is relatively for beginners, and I think it's very nice to get started with.